Hello everyone. In this video, I'm gonna talk about Python type checking, and these are the contents that we are gonna talk about, and some terminology before we go on talk on those topics. Here, source code. Code is usually written by a human into a computer, and the translation to convert source code into machine code so that the computer can read. And the runtime is the period when the program starts to execute the commands after compilation, if compiled. And then the compiled is to translate the code before runtime, and then interpreted to translate the code on fly during the execution. This means executing the source code line by line. Now we can discuss about the dynamic typing. So Python is a dynamically typed language. So it means Python interpreter does type checking only as code runs. Hence, the underlying type of variable is unknown until it is used. So if an attempt is done to use a variable which is not supported by the underlying type, then we get a type error. Also, if a branch of code is never visited, the errors can lay out for years. For example, here we can check a hidden error and a little bit more explanation about this code. So as long as the argument variable is something that is comparable with the condition, if condition here, it returns true and the code will run without having any problem. But if this statement's false, then we get an error because of this, because there are two different types. So let's run and see what will happen here. 2 here and run. So which is fine, it prints because the condition is correct. And then if we give -2, let's see what will happen. So we get an error because of unsupported operand types, int and string. So in Python or in dynamic typing, the type of variables is allowed to change over its lifetime in runtime. So let's see what it means here. For example, I have a variable that I assign to a string, and this is the type function that we can use to check what is the type of the variable. So let's run and what will happen. So this is the string here, and now I assign to the value 10, number 10 here, and let's check here the type. So it gives int. So now we can discuss about the static typing. So in static typing, types are checked before runtime. So this means that erroneous usages of types can be caught before the execution. And the types of variables generally is not allowed to change, but typecasting exists in static typing. So this is a Java example. Here is the type string. So when I assign a string here, and also when I assign int type, then we get an error because of incompatible types of types even before we execute the code. This is unlike Python. So here in Python, the problem with correct types can be solved by using of an informative docstring. If you remember docstring, before we have discussed how docstring will help us to understand the arguments in the function and what it means, right? So however, there is also another way to help the user by in order to avoid a type error by using type hinting. So it's a tool that allows developers to annotate the expected type of variables and also returns of a function. However, it is very important to note that it is not enforced by the language, so third-party tools must be used to control the typing. So here, so the type of the variable, the syntax here is annotated variable name and then the type here, and this is for return in a function here. So I'm going to show you an example here in the next block. So here, the first I have two examples, one with type hinting and another one is without type hinting, so we can see the difference. So the first one here, arithmetic, I called the function arithmetic and I gave it two arguments, and then I said the addition is true. and I have the if addition, then we have a addition, or otherwise we have a multiplication. So let's check what will happen if I give 1 and 2 as a arguments. Then I get the output number 3, which is correct. So now what I said, the default is true. So now I see I said false. So what will happen? I get 2, which is also correct because 1 multiplied 2 is 2. But here in the third statement, what I did, I said false, but I made it a string. So let's run what will happen. Oh, I get 3. But actually it is wrong, right? Because of this. But at the same time, we are not getting any errors because it's just giving output as it has no problem. So to catch this type of errors, we can use type hinting. Let's look some same example with type hinting here. I just call it arithmetic 1, so the distinguish between those two. I just added 1 here. And then here, as you see here, this is the type hinting. We specified the type of the arguments here, and also for this is Boolean. So, and also the return type here is int. And now we can run in a minute, soon what will happen. So for this also, when we use type hinting, we need to follow also the PubPet guidelines. For example, here I have given some information. 1 space after the colon. So this is here, 1 space. And also it is a default, if a default value is assigned to variable, the assignment operator is to have 1 space on each side here. So we have 1 space here and the 1 space before and after the symbol. And then also the arrow annotates the return type is to have 1 space on each side. So this is here. I have 1 space here and 1 space here. So now let's call the function with type hinting. So as mentioned before, also type hints are not enforced. So because Python is dynamically typed language, and as such, variable cannot be statically assigned a type. This means that even if your function is perfectly documented with doc strings and type hints, it is up to us to call it in a correct way. So user type hints allow tools to help out even more. For example, most IDEs can do that. Also static type checkers. So we can check what it is. A static type checker means. So a static type checker is a tool that travels the code with the purpose of finding places where a variable or argument has no expected type. So for that, we use there is a MyPy tool used statically control Python code. So this is the syntax here for running in terminal. And in our example, I call the code that we have. I saved the code that we just had before with type hint.py file. So I can just take this here and run it in terminal. Just open the terminal and here. So now it catches the error, but before without type hinting we couldn't do that, right? So the same error I have it here. Argument addition to arithmetic 1 has incomplete type string expected Boolean. So this is how the type hint helps. So now we know it's a Boolean type. So type hints are not reinforced in Python language. So type hints need to be controlled by the developer or self-enforced. So however, regular running 1 or more static type checkers can prevent many subtle bugs that comes from working with a dynamically typed language. So now let's talk about duck typing. So duck typing, the name comes from a term duck text, often described as if it looks like a duck, swim like a duck, and quacks like a duck, then it's probably is a duck. So duck typing can can make code reusable and provides an implicit interface that can be matched by any object. In duck typing, the type or class of an object is less important than the method it defines. So when we use duck typing, we do not check any types. Instead, we check for the presence of methods or attributes. So let's see an example to have a better idea of duck typing here. So I have 3 classes for animals, and I have functions: wings for duck and also wings for bats, and but the fish I have a swim. So now I call an object animals and run, and let's see what will happen if I run this. So the first 2 ones, because animals, the object has wings here, function, and also here. So duck has wings and it flies, bat has wings and it flies, so it prints the statement we have. And then what will happen for the third one when it goes to fish class? So we get an attribute error because fish object has no attribute wings. So as mentioned before, so in this example, we do not check do not check types. Instead, we check for the presence of a method or attribute. So yeah, that is what I want to explain in this video for type checking in Python. And for more information, you can also visit realpython.com. Thank you very much.